In this question, we are given that there is a uniform rectangular frame, uniformly dense rectangular frame ABCD. This rectangle has total mass capital M and it is made of wire of uniform density. Each diagonal has length D. Angle between the two diagonals is theta. What we have to find? We have to find moment of inertia about any one diagonal, say AC, of this whole frame in terms of M, D and theta. That means about AC we have to find angular momentum, moment of inertia in terms of these three parameters. And answer should come out to be md square by 12 sine square of theta. We should try and get it and then see the solution. Let us discuss the solution. There may be other methods also, but one method I am going to use, that suppose this is a line, say any line, and a uniformly dense rod is inclined with this line at angle, say alpha, and this line has mass M, length L. What we have to find, if this line is say OA, this, let us say this axis OA, we have to find I about this OA of this line, or you can say rod, you can say this is rod uniformly dense of mass and length L. We have to find its moment of inertia about this line or axis OA. This result is that ML it will equal to ML square by 3 into sine square alpha. How it comes? Let us see. We can imagine a small element here, say of length dl, and it has mass dm. And say this element is, और let us say call it dx, l तो एक फिक्स वैल्यू है और इसकी लोकेशन O से एक्सिस्टेंस पे है. तो this dm mass, which is of very small length dx, its moment of inertia about this OA will be, let us see this height, a height will be, this height will be x sine theta, sine alpha. So to feel moment of inertia of this element, we can imagine a circle like this, whose radius will be x sine alpha. So moment of inertia of this element will be this dm into x sine alpha square. We can call it di. So di is dm into x sine alpha square, and dm can be written as m by l into dx, because total mass is m, total length is l, unit length ka mass of unit length will be m by l, so mass of dx will be this much, and this x square into sine square alpha. So we will get I as integration of di, and that will be integration of this whole expression. X limit will be 0 to L, and it will come out to be ml square by 3 sine square alpha. So we are going to use this relation. Now let's see if we have to find I about this line AC of this whole frame. So we can find it one by one. We can find I of AB, then I of BC, and just double it, because this side and this side will have same I about this diagonal, and this side and this side will have same I about this diagonal due to symmetry. So I of this side AB, it will come out to be, if its mass is MAB, then MAB into AB whole square by 3 into, if this angle is say alpha, then here we have sine square alpha, using this result, this one. Now we can replace the parameters in known quantities. What will be MAB? It will be lambda into length AB, so it will be lambda into AB cube by 3, and sine square alpha. I am leaving alpha as it is. Similarly, we will have I of BC about this axis. So we will use this angle. Say this angle is beta. For simplicity, we can assume beta. We will replace in terms of theta later on. So this will be lambda BC cube, just like I of AB, sine square beta. This expression is similar to this one. And AB length and BC length can be written in terms of D and theta. AB will be equal to this AB, D cos alpha, And what about BC? BC will be equal to D BC, this is BC, D cos beta, right? D cos beta. So I of AB plus I of BC. That means I of AB plus I of BC. If we add these two, then to get total I, we can double it. So our required I is this much. Now we will simplify it twice. Add these two with this replacement. So 2 lambda by 3 will come out. We can write cos cube alpha sine square alpha plus BC cos cube beta sine square beta, and then D cube. If we replace these two, AB and BC here, AB, this expression cos cube alpha jayega, and here we will get cos cube beta. So this expression D cube will be outside. Can be taken outside. This will be 2 lambda by 3 D cube if we replace this, we can realize here that alpha plus beta will be 90 degree. Alpha plus beta will be 90 degree. The beta can be written as 90 minus alpha we write beta as 90 minus alpha, 90 minus alpha. So we can take cos square alpha and sin square alpha common, and we will get remaining term cos alpha plus sin alpha. What about this lambda? Lambda is mass per unit length. The total length will be twice of d. Total length will be basically twice of this length and twice of this length. This is d cos alpha, this is d cos beta, and cos beta is nothing but sin alpha. This plus this is 90 degrees, so we have 2d cos alpha plus sin alpha into lambda as capital M. So we can write lambda as m upon 2d and 1 upon sin alpha plus cos alpha. So this is 2 by 3. We can remove this expression. 2 from here, we replace alpha. There will be md square by 3, and then this will cancel out from this expression, and we replace this expression for lambda, and here we will get cos square alpha sin square alpha. It will be md square by 12 sine of 2 alpha whole square, sin square 2 alpha we can write. But we have to get the answer in terms of theta. So we can realize if this is alpha, this is also alpha. This is also alpha. And this will be 180 minus theta. So we can write 2 alpha plus 180 minus theta as 180. So clearly theta equal to 2 alpha. Or you can write directly, this is exterior angle to these two angles, so theta is 2 alpha. So you can very well write here theta. So we have got the answer as md square by 12 sine square theta. Right? This is more of mathematical. Only thing is that if we realize this basic result and then this mathematical relation between dA and alpha beta and properly replace linear mass density here. Linear mass density into total perimeter is total M. We will get the answer.